All right, here we go. Let's do problem number 3D. All right, so this is the first one on the target check where we've got both horizontal and vertical forces. Please remember, when you're adding up forces to find your net force, at any given moment, you should only be considering the vertical forces, which we call the Y forces, right? Because the Y-axis runs vertically, or horizontally, which we would call the X forces, right? Because in math class, you've got an X-axis, which runs horizontally, and a Y-axis, which runs vertically. So anytime you have a little X subscript, that means horizontal. Y subscript means vertical, okay? So let's start this out here and see if we can figure some stuff out. Okay, so we got an 80 kilogram box sitting on the floor. So let's start there. So here we go, here's the floor, here's the box, 80 kilograms. Every time I make a free body, Every time I make a free body diagram, I should start with my force of gravity. So let's go ahead and do that. Force of gravity, 80 times negative 9.8 gives you negative 784 newtons. Okay, so that's always step one. Step two, any given forces. It tells us that Roy pushes horizontally. So let's go ahead and put that into the drawing. Here's our force of Roy, 300 newtons. Now I could have made this force to the left. It doesn't really matter. I always just assume that when Roy's pushing something, he's pushing it forwards, which is to the right on your paper, okay? If you had him pushing it to the left, that's fine. You're gonna have negatives where I have positives, and your drawing will be backwards, okay? All right, and then it gives us the acceleration, 3 meters per second squared. But notice, he's not trying to lift it, so the acceleration is gonna be horizontal, right? So in keeping with what I was just talking about, let's do this. Everything that is horizontal, I'm gonna do in red, all right? So this is a horizontal acceleration. All right, I'm being a little bit over detailed here, just to kind of emphasize a point. You don't have to put all those little X's on there, but just kind of helping you process, okay? Okay, cool. Well, as always, remember, there's two ways you can find net force: mass times acceleration, or add up all your forces. Well, here, I know my acceleration, so let's go ahead and find my net force. But my net force has to be horizontal, doesn't it? Because all of the motion is horizontal. So let's do this. So net force horizontally is mass times horizontal acceleration. So 80 kilograms worth of mass, 3 meters per second squared worth of acceleration. Multiply that out and you get 240 newtons. All right, so what other horizontal forces are there? Well, it tells us, I guess I gotta stick with red. It tells us there's friction. Okay, so I think my net force horizontally is the force of Roy plus the force of friction. Notice I'm not going to include gravity here because it's not a horizontal force. We're going to deal with gravity in a minute. Okay, and if you'd wanted to, you could have dealt with gravity first, which I'll explain in just a second. All right, so at this point, all I'm worried about is the horizontal motion of the box. Okay, so I'm just worried about horizontal forces, horizontal acceleration. All right, so let's see. I know my horizontal force horizontally is 240. I know I've got a force of Roy plus some friction force. Subtract 300. Oh, my friction force is negative 60 newtons. Go ahead and put that on your drawing. All right. Now, what about vertically? We're going to do everything vertically. Well, Mr. Hernandez, I am finishing up a video. Oh, phooey. Did you get some food, Mr. Hernandez?
I did.
Neat. Did you buy yourself a Mountain Dew?
I did not.
Oh, such self-restraint. Amanda will be proud of you. Okay, so we did our horizontal stuff, so now we got to do our vertical stuff, right? So vertically, what do we know? The box is just moving along horizontally, right? It is not moving up or down. And so what that means is vertically, there's no acceleration, right? My acceleration vertically is 0. Oh, that means my net force vertically has to be 0. Huh. Well, why isn't the box falling through the floor? Oh, well, there has to be a normal force, right? It's sitting on the floor. Whether it's moving horizontally or not, the floor still has to be holding it up, okay? So there has to be a normal force here of positive 784 newtons to ensure this, okay? Please notice your free body diagram includes all of the forces acting on an object. So even though these two forces don't really affect the motion of the box, we still have to include them in our drawing because they are forces acting on the object. All right, cool, cool. I'm gonna go see if Mr. Hernandez needed something other than me talking to him. I'll see you before after school or during student support if you need help with this, all right? Talk to me. I like helping people. I do want to stop recording. Thank you for asking.